In the previous video, we had discussed what is oxidation number and how to calculate it. In this video, we are going to look at how oxidation numbers are used to determine whether the given substance has undergone oxidation or reduction. Any change in oxidation number indicates that a process of oxidation or reduction has taken place. Increase in oxidation number of a particular atom or ion is due to the loss of electrons, and it is oxidation. We have taken some unbalanced reactions to explain. First one is combustion reactions, carbon to carbon dioxide. We have to assign oxidation number to carbon both on the reactant and product side. On the reactant side, it is 0 since it is in the elemental state. And in carbon dioxide, the oxidation number of carbon is plus 4. There is an increase in oxidation number from 0 to plus 4. It indicates oxidation. Similar is the case with the combustion of sulfur to sulfur dioxide. Here, the oxidation number of sulfur increases from 0 to plus 4, indicating oxidation. Next one is tarnishing of silver. You would have observed that when silver articles are exposed to air, a dark coating is deposited on them. It is known as tarnishing of silver, and the chemical process is silver is converted into silver sulfide. So, therefore, when we look at the oxidation number of silver, as usual, both on the reactant and product side, on the reactant side, it is 0 since silver exists as element here. Then in silver sulfide, the oxidation number of silver is plus 1. So 0 to plus 1 means it is oxidation. The next one is liberation of iodine from iodide. Say for instance, iodine is liberated from potassium iodide. In iodide, the oxidation number of iodine is minus 1, and when it is liberated in the free state, its oxidation number is 0. Therefore, minus 1 to 0 means it is an increase in oxidation number indicating oxidation. Decrease in oxidation number is due to gain of electrons. It indicates reduction. Let us look at certain examples. The first one is formation of hydrogen chloride. The oxidation number of chlorine on the reactant side is 0, and on the product side it is minus 1. Therefore, there is a decrease in oxidation number from 0 to minus 1. It is reduction. Whereas it is obvious that hydrogen is oxidized. The oxidation numbers of hydrogen are marked in green ink here. It changes from 0 to plus 1. Therefore, hydrogen is oxidized. Second one is conversion of bromine to bromide ion. Here, the oxidation number changes from 0 to minus 1. It is decreased. Therefore, it is reduction. Formation of nitric oxide from nitrogen peroxide. In nitrogen peroxide, the oxidation number of nitrogen is plus 4, whereas it is plus 2 in nitric oxide. Therefore, we infer that nitrogen peroxide is reduced to nitric oxide, and since the oxidation number of nitrogen decreases from plus 4 to plus 2. It is not necessary that all the reactions should have the process of either oxidation or reduction. There are certain reactions where there is no change in oxidation number. The following unbalanced equation where dichromate ion Cr2O7 2- is converted into chromate ion CrO4 2- is an example. We have to assign oxidation numbers to chromium both on the reactant and on the product side. On the reactant side, in the Cr2O7 ion, the total oxidation numbers due to 7 oxygen atom is 7 into minus 2. And the algebraic sum of the oxidation numbers of 2 chromium atoms plus that of 7 oxygen atoms is equal to minus 2, which is the charge of the ion. Therefore, for 2 chromium, it is plus 14 minus 2, and for 1 chromium, the oxidation number comes to plus 6. On the product side, for CrO4 ion, the oxidation number of 1 chromium plus that of 4 into minus 2, that is due to 4 oxygen atoms, is equal to the charge of the ion, that is minus 2. Therefore, for 1 chromium, it comes to plus 6. Therefore, there is no change in the oxidation number, and neither the process of oxidation nor the process of reduction is taking place. Many more examples can be added. In the given unbalanced equations, we have to identify the element which has undergone oxidation and also the one which has undergone reduction. And the changes in their oxidation numbers are also to be found out. For this, the oxidation number for each element, both on the reactant and product side, are to be determined. First, dichromate ion Cr2O7 gives rise to Cr3 and Fe2 to Fe3. For chromium in dichromate ion, just now we have calculated the oxidation number. It is plus 6. And in Cr3 on the product side, it is plus 3. Therefore, for chromium, oxidation number decreases from plus 6 to plus 3. The change in oxidation number is minus 3 and chromium is reduced. For iron, the oxidation number on the reactant side is plus 2 and that on the product side is plus 3. So there is an increase in oxidation number. Iron is oxidized. The change in oxidation number is plus 1. The second unbalanced equation shows that permanganate ion MnO4-1 gives rise to manganese ion Mn2+, and ferrous ion Fe2+ gives rise to ferric ion Fe3+. Let us calculate the oxidation number of manganese on the reactant side. In permanganate ion, the total oxidation numbers due to 4 oxygen is 4 into minus 2. The algebraic sum of the oxidation number of manganese plus that of 4 oxygen is equal to the charge on the ion, that is minus 1. Therefore, the oxidation number of manganese on the reactant side is plus 7. On the product side, it is plus 2. Therefore, the oxidation number of manganese decreases from plus 7 to plus 2 by minus 5. It is reduced. Whereas for iron, on the reactant side, the oxidation number is plus 2 and on the product side, it is plus 3. There is an increase in oxidation number for iron by plus 1. It is oxidized. In the next one, lead peroxide PbO2, it's a neutral compound. It is converted into Pb2+ ion and chlorine is liberated from chloride ion. In PbO2, the total contribution by 2 oxygen atoms is 2 into minus 2. The algebraic sum of the oxidation number of lead plus that of 2 oxygen is equal to 0, or the oxidation number of lead on the reactant side is plus 4. On the product side, it is plus 2. Therefore, for lead, the oxidation number decreases from plus 4 to plus 2. Lead is reduced and the change in oxidation number is minus 2. Coming to chlorine, The oxidation number of chlorine on the reactant side is -1, and on the product side it is 0 since it is in the free state. Therefore, for chlorine it changes from -1 to 0, or the oxidation number is increased and chlorine is oxidized. The change in oxidation number is +1. If you find this video useful, then share and subscribe. Thank you so much.